This video will be explaining through the answers to worksheet number 2, which was due yesterday, as well as talking about the questions at the bottom and going over what you guys are going to be working on for the rest of this hour and for our hour on Wednesday. So, first, please be aware as you are looking at this key, I did add a new column because I thought it would be helpful. The difference between aphelion and perihelion, so I added this new column here. If you guys are looking at this and you are kind of confused, please make sure you guys go back through and watch the video with some helpful hints, because I'm not necessarily going to explain through the chart. What I did for the chart is I just repeated the exact same process to find the major axis, aphelion, the perihelion, and then the focal distance, and then I just subtracted our aphelion from perihelion for the difference between them, right? So major axis, again, just a reminder, what I did is I just doubled the semi-major axis, because if you think about it, major axis is just the from one side to the other. The semi-major axis is from one side to the middle, so you just have to double that in order to get your major axis. Then the focal distance is really just your eccentricity times your semi-major axis. So all you have to do is multiply these two columns together. So that's where I got this answer from. The aphelion, you add your semi-major axis, so from your outer edge to your inside, and then you take half of the focal distance, because your focal distance is from one focus to the other. So now you want from the center to the focus, so you want half of that focal distance. So I did half the focal distance plus my semi-major axis to get my aphelion, and then I did my semi-major axis minus half the focal distance, and that's where I got my perihelion from. And then, as I said, I just subtracted the aphelion from the perihelion to get the difference between them. And then I repeated that for Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Some of you might have really just kind of figured out you're doing the same thing and created like a Google Sheet, which is kind of what I'm showing here. But I will get to what I actually put in here for my data later. Excuse me. But anyway, down to the questions. For which planet is the difference between aphelion and perihelion distances the greatest, and why? So if you look here at the differences, this column, the only column you guys don't have, the difference between them should be 1.7694, which is again our largest, and that is because it has a large orbit and it's a decently large eccentricity, right? So if we look at our biggest orbit, that's Neptune, but Neptune's not very eccentric. It's not very squished, right? Let's just make it simple. I don't think there's another word for that. If you look for the planet that has the smallest difference between aphelion and perihelion, that would be Venus, because Venus has a very, very small orbit, and it's not very eccentric at all, right? So it has a very, very small difference between its aphelion and its perihelion. 3. Develop a claim about the relationship between eccentricity, perihelion distance, and aphelion distance. The greater your eccentricity, the greater your distance between your perihelion and your aphelion. Or the greater your eccentricity, the greater the aphelion is, and the smaller your perihelion is. So in order to explain that a little bit more, I filled out this chart where it's calculating the major axis, aphelion, perihelion, the difference between them, and the focal distance. It's doing all of that for me, which is super helpful. But what I want you guys to notice is that I put all of them at a semi-major axis of 1, right, which is what Earth's semi-major axis is. So if you go up here, Earth has a semi-major axis of 1 astronomical unit, right? So I kept all of them at 1, so all of them have the same orbit size as the Earth. But what happens if you make that orbit really, really, really not eccentric, or if you make it really, really large in terms of its eccentricity, right? So what's going to happen here? So notice that the major axis is always 2 here, and then notice that my aphelion right, perihelion, and the first one where their eccentricity is not very high, they're pretty close to each other, right? But then as you go farther and farther up in terms of eccentricity, notice that the aphelion gets much, much bigger, and the perihelion gets much, much smaller. Um, so that's all I'm filling out here, is I just changed the eccentricity, and it's increasing as we go down, and you can see that the aphelions are going up and the perihelions are going down. So the difference between them is increasing as we go through this. So that's kind of confirmation on what we just said here. The greater the eccentricity, the greater between them. The greater that the aphelion will be, and the smaller that the perihelion will be. So the final question. Number 4, how does the temperature or the seasons relate to the claim above? So the reason that I said that the more elliptical the planet is, or the greater the eccentricity, the greater the variation in temperature and seasons, is because if we get to the point where we have a very high eccentricity, there's a huge difference between when you are really, really, really close to the sun and when you are really, really far away. All right. So that is going to make a difference between the seasons, and it's going to make a huge difference in terms of what temperature you feel and what the weather is, right? Whereas for us, because if you look back at Earth's eccentricity is pretty low. So for us, there's not a huge difference between our aphelion and our perihelion. So for us, we don't feel the seasons because of that aphelion and perihelion. We feel that because of the tilt, right? But on certain planets, you might see a huge difference in seasons, not because of a tilt, but just because of the eccentricity of that planet, where the aphelion is so much farther away than the perihelion, right? Whereas if you look up here at Earth, aphelion and perihelion, there's not a huge difference between them, right? So there's not going to be seasons caused by that. Our seasons are caused by the tilt of the Earth. So we're going to have a dramatic effect when you increase the eccentricity of a planet. That will have a huge impact on temperature variations and seasons, right? So you're going to feel much, much hotter when it's close at perihelion and much, much colder when it's at aphelion, right? But that's not necessarily the case for us because we aren't very, we don't have a very high eccentricity. Final thing I do want to talk about is the gravity explorations. You guys should have noticed that yesterday I uploaded the gravity explorations. They are in the form of a PDF. I apologize I couldn't get them into a Word document or a Google Doc. So these are in terms of a PDF, so you can either print them out or you can find a PDF editor. Okay, there are plenty of PDF editors on the internet. Just find one and then put your numbers in as you go. The easiest solution for a lot of you guys is going to be just printing it out like I would in the classroom and then filling it out on the paper. Please also be aware that you will have to be switching between 4 different interactives on the physics classroom. So click on this link, circular and satellite motion, for this first one. And then what you guys are going to be doing is you are going to be using gravitation. You're going to be using the value for G. You're going to be using the value of G on other planets, and then you're going to be using your weight on other planets. So you'll be using all 4 of those interactives throughout this activity. The final thing that I want to mention about this is not due until next week, Wednesday. Right, so yes, you should start working on it now, and you should probably get at least through this front page. But then I will give you next Wednesday to work on it as well. So this is something that in the classroom I would give you about 2 days to work on, and then it would be due. So I'm giving you the same thing in this online space. Please do not procrastinate and wait until next Wednesday to start working on this, because then yes, it's going to be a lot of work, right? And then at that point it will be too late to ask me questions. So please get started on this. And at least work your way through the first couple pages, and then the rest of it should be pretty easy on Wednesday. So if you guys have any questions about editing it as a PDF or you don't have a printer, please let me know. I'm here to help. Okay. Another thing that's going to be helpful going back to worksheet 2, if you want to pause the video here and ignore this column, that'd be awesome to just double check your work. see that you did it right. Okay. Just final thing on that. All right. Have a good day, guys.